So now that you've tried some questions using the binomial distribution, I'll show you how you can use Excel to do a number of questions very rapidly and set up a number of simulations. So first thing, remember in the last assignment, you had a question where you were asked to develop a binomial distribution for an event where you were going to run a total of 5 trials where n is equal to 5, where the probability of success would be 20% or 0.2. In this case, the probability of failure would be 80%. So if we're going to run 5 of these individual trials, then we could have 0 successes, we could have 1 success, and we could then go right up to a total of 5 successes. So if we have running 5 trials, this would be our number of successes. And we're going to calculate the probability of this binomial distribution. So now what I'm going to do is format this as a table. Just so that I can get this to work very easily. So I'm going to type in here a formula equals, and there's an Excel formula called binom.dist, and that's for the binomial distribution. And you'll notice the first thing we have to put in is number underscore s is number of successes. And so I'm just going to click on the cell with 0 successes in it. Then comma, number of trials will be, in this case, 5. Comma, probability of success is going to be 20%. You can either express it as a decimal or as a percentage. And last is cumulative. Now, cumulative means that it adds up all, gives you a running total of the percentage or the probability of that. So in this case, I want to know what the probability of 0 success is, 1, and so forth. So I put in false. And it returns this solution. So now if I'm going to insert a chart, if I'm going to insert a chart, you'll notice I'm going to have to format the axes here and select data. And what I want here as my y values is the probability. And that's a much better chart for this. And quick layout, I want labels. And I want separation between them. There we go. So I can change the axes here to number of successes. And on the vertical axis, this will be our probability. Okay, so now we've done that, I'll just run through this quickly again. If the probability of success is 50% and the number of trials is 8, again, we're going to have up to 8 successes and right down to 0 successes. So this would be like flipping a coin, because the probability of heads is 50% and the probability of tails is also 50%. So put this into a chart again. So equals binomial dist. Number of successes would be 0. Number of trials is 8. Probability of success is 50%, or I'm going to put in 0.5. And cumulative, this time I'm going to put in true. And you'll see what this does in just a second. So what it has done here is you have about a 0.39, it's about 0.39% chance of having 0, let's say in this case it's heads. One head, the probability of getting 1 or 0 heads would be about 3.5%. Probability of 0, 1, or 2 heads would be about 14%. So if I change this formula to false, then you can see how that affects it. If we take the sum of these three, then that's that number we saw before, the 14.45%. And if we want to know then, if the question is, what is the probability of getting between, we'll say, anywhere from 4 to 6 heads, that means that you would get 4, 5, or 6 heads. So if we ask that question, then it would be just a sum of 4, probability of 4, probability of 5, and probability of 6. Click that. So equals sum. So if we want to know what the probability of getting 4, 5, or 6 heads, we just add up those probabilities. And so if you toss a coin 8 times, then you would get 4, 5, or 6 heads, any of those, 60% of the time.